inventories. I must say, I just presented myself. I'm also responsible for the NFI in Flanders. This is the fourth conference now that I'm attending to, and I've never given a presentation because I would think Flanders, it's so small, our forests are so small, we hardly have any forest. So personally, I'm very interested and happy that the first speaker from Ireland, I know that Ireland has a forest cover of about 10-11%, I think, which is very similar to Flanders, so I'm very interested in that. The first speaker from Ireland is Twomey.
Thanks, Lee. So I'll just go straight into it. Just the areas I'm going to be covering in the presentation. Just an overview of the project itself. Firstly, the objectives and all that behind it. Sampling design and airflow interpretation, technology, NFI technology we're using, data collection, data processing, and the NFI results. I've just looked at a summary of those, and some of the change results as well, because we're on our third cycle at the moment.
Mark, you have to speak louder.
Sorry, okay. I'll go louder. So the National Forest Inventory is a statistical sample survey of all forests in the state. The purpose is to record and assess the current extent, state, composition, and change to Ireland's forest resource, both public and private, in a timely, accurate, and reproducible manner to enable the sustainable development of our forests. So, well, national reporting is a huge element and international reporting of the reasons why we actually carry out the National Forest Inventory. So the primary output are providing results at a national level with reliability estimates based on a 95% confidence interval, specifically in relation to growing stock, increment, forest area, carbon, forest health and vitality, harvesting, and species composition. So it's 5 to 6 year periodic NFI cycle. So we're in the middle of our third one now. The first was the data collection period. The first one was 2004 to 2006. Second was 2009 to 2012. And we started our third one in 2015, and we're due to finish in June 2017 in terms of the data collection element. So we'd be hoping maybe to publish results by the end of 2017, early 2018, that kind of way. So this is the sampling design. It's a 2 kilometre by 2 kilometre randomized, systematic randomized grid. So at each point, you're probably familiar with this, the plot centre is randomized by about 100 metres around the grid intersections themselves. That's just an example from one of the counties, County Wicklow. So at each grid intersection, we put down the base map of an air photo. We have 2004, 2006 1 metre resolution air photos, which we use, and then the more recent Bing imagery from 2011 to 2013, which is much higher resolution. So at each point, if we're seeing forest underlaid, we're putting down that as a potential permanent sample plot initially. And the result of that kind of initial desk study is 1,800 potential ground sample plots. And everything else as well is put into a land use type classification as well. So we will do a complete survey of the land base of the country and put them into a land use type classification, which can be used in other areas. This is just a map of our permanent sample plots, where they're located. They're just, as can be predicted, hitting the high density forestry areas. So West Coast is a big area for us to cover. Basically, that's where the majority of the plots are. And then going to our definitions on forest. So it's land with a minimum area of 0.1 hectare, minimum width of 20 metres. Trees higher than 5 metres and cannot be covered more than 20% within the forest boundary. Are trees able to reach these thresholds in situ? And I suppose another major element of our definition is teasing out what exactly the forest boundary is, and just coming up with rules for that. We can use with high resolution equipment as well. We can be pretty exact on what's a boundary, what's a forest, and what's not. So that's where the technology becomes really useful when we're down at ground level with accurate GPS and so forth. And then forest area is a non-stopped area enclosed within the forest boundary. For example, ride lines or setbacks from streams as well. So that's everything within the forest boundary itself. This is just an overview of some of our technology. I think you're familiar with a lot of these. TruePulse 360R there and the Hammerhead XRT. And then of course we're using field map for preparation of the data collection project, navigation to inventory plots, field survey of inventory plots, the validity checking of data, database management, pre-processing of data, statistical data processing, and publication of results. So start to finish, very useful for the whole inventory itself. And then these are some of the, you're probably all familiar with these elements of field map as well, the project manager, data collector, and inventory analyst. And we've also used STEM analyst as well to create broadleaf models in 2013. But I'll have another slide in that, I'll talk about that in a while. So just some of the hardware behind it again. The Hammerhead XRT is the field computer we're using. It's virtually indestructible. We found it very useful for the last 12 years or more we're using it, so it's very good. And I suppose in Irish conditions, IP67 is a major requirement because of weather and all of that. So we found it's it's the best machine for field usage. And then more recently we would have purchased SX Bluetooth GPS from Genec, I think it was, and they're quite useful for establishing new plots, we would say, because they're under the open sky we can get quite good accuracy, possibly 30 centimeters, 1 meter, that kind of thing. So they're very good for establishing new plots without canopy as such. And then the laser we're using is the TruePulse 360R, and then accessories associated with all this hardware: harness, monopod, cables and batteries, rechargers, port replicator scopes, slasher from the saw, and Bluetooth communications mainly between the instruments as well. So we have going there, so just reducing the need for cables and that in the field. So I'll just have a look at the data collection side of things. So I said there's 1,800 permanent sample plots and 145 attributes per plot, so there's quite a lot of data collection at each individual plot. We have 3 two-person teams currently going through the country, and we divide projects on a county basis. So that's kind of the administrative boundary really. And it takes us 20 months, including the training. So it's somewhere around 2 to 3 plots a day, mainly 2 plots a day. That's what it roughly comes out at. And there's year-round data collection, so fortunately or unfortunately in the middle of winter we can still keep going in terms of the weather. And then this is just our plot design. So we have the concentric circle plot design to reduce the workload and work time as we finish the plot. So it's subsamples of each plot. So for example, at the center is a 4-meter radius plot, and we have a threshold of trees for mapping, which is 70 millimeters dBH. So everything below that we don't map. And then outside that circle between 4 and the 7, we have 120 millimeter dBH threshold in those trees, and beyond it again, beyond the 7 to 12.62, we are looking at a threshold of 200 millimeters there as well. So the whole plot is 500 meters squared, and working up to a national scale, they represent about 400 hectares each plot. So these are qualified trees for mapping. But we also collect data on small trees as well, which are not mapped. So the database structure, so it's a fully hierarchical structure, 29 tables and 145 attributes. The field database is in Firebird and GS Partners with shapefile, and the map, as you probably know, exports data in Access, DBase, Excel, and XML. So these are kind of the various checks that we have as well. Online checks for the field teams prior to leaving the inventory plot. So missing data check. So searches for all missing information which are required in that. Missing items, check data output files, so it throws up that file there in the middle that you can see. And data verification script. So looking at logical relations, let's say taper and that kind of thing to see if everything makes sense, basically, in terms of the description of the trees. And then, of course, you have a visual check of the DPH distribution and height graphs there as well. And then the operator can just correct the data before he leaves the field. So we have a big emphasis on trying to get everything right there and then before they leave. And we also have a lot of checking back at the office as well, just to make sure that that everything makes sense. We do other checks in Microsoft Access as well, on top of this over the whole database, just to make sure the data is clean and all that for pre-processing. So in addition, we carry out a validation on all our teams and their work, and it's a joint effort between INNOFOR and ourselves. And we use custom designed validation software, and there's 100 plots randomly selected throughout the country. So we do this in kind of 2-week stints, usually about 25 plots that we randomly spread throughout the country. So as we try to keep it going along throughout the 20-month period, every 4 or 5 months, that kind of thing, to feedback to the teams quickly if there's something going wrong or something else needs to be standardized, the approach. And in addition, at the start, we would sit in the team for maybe 2-3 weeks in addition to training, just to mentor them along on site, just to make sure the data quality is up to standard as well. And then, of course, the information from this feeds back to us to determine what kind of checks we might need at the desk side of things as well. And here I'm going to look at the data processing afterwards. So some of the methods, you're probably familiar with modeling, for example, tree volume, classification, looking at diameter classes, aggregation, number of species per plot, reclassification, for example, species groups, and post-stratification, county, as I said, are kind of administrative boundaries. And just in terms of the models that we're using or have used, for the first NFI, we were looking at the British Forestry Commission single tree volume equations by Matthews and Mackey. So we would have used that for the 2004-2006 data initially, and then single tree stem profile models for 6 conifer species was developed. And this is based on historic research data from destructive sampling. And then more recently in 2013, single tree stem profile models for 4 broadleaf species were developed, and that was non-destructive, so looking with a remote diagnoscope and using field map stem analysis as well. And the new models use DPH and height to generate the volume. And then in terms of the performance, it's quite good. The R squared of 0.99 and 0.97 for the conifer and broadleaf models respectively. Okay, so some of the terms you're probably familiar with. Processing, evaluated variables such as area, volume, number of trees, stratifier, post-stratification, decrease in variance, classifier, species, diameter classes, solid groups, just a way of grouping the data prior to processing. So some of the calculated statistics that we were able to generate from field software, totals, total area, volume, etc., mean values, mean volume, mean height, mean defoliation, mean of total, mean of means, mean of weighted means, normalized mean of totals, normalized mean of weighted means, with a confidence interval of 0.05. So just having a look at some of the results, probably an interesting part, and just how the standardized outputs displayed this Royal Enfield map. So just the classes we're looking at there in the top left. Calculated statistics here, and confidence interval we're getting with them, and percentage, and totals and subtotals. So that's just showing the very species and volume associated. I think that's from the first NFI, and then some of the outputs charts as well that we're generating here now. So then this is kind of some of the more interesting stuff from ourselves from a monitoring point of view, just to see how the National Forest estate is moving and where it's moving. So we're at a very low percentage in Europe at 10.5% cover in 2012. So we're still in a job of building up forest cover in Ireland. And as you can see, it's coming up to 10.5 in 2012. So that's 750,000 hectares roughly. And then in terms of the ownership of our forests, it's between public and private, so there's semi-state forests, and they have 389,000 hectares, and 342,000 in the private. And you see again the share of the private forest is increasing from 2006 to 2012. So it's I suppose we've had a lot of incentives for afforestation over the last number of decades, so it's just tracking that as well. And then it's just useful to see the age classes as well, the majority of our forests and where things are happening. So we can see the majority are really in the 11 to 30 age category. So we're kind of moving into a tinning phase. A lot of tinning is what we're trying to promote and mobilizing timber basically for industry. So we know where we need to concentrate. It's providing good data for that as well. And just as well, you can see that it's the private stuff is getting to that. It's getting to that age, coming to tinning age here. So it's kind of like we know where to target our policies, looking at to promote tinning and so forth. And then looking quickly at the species composition. So Sitka spruce is the primary species, followed by short-living broadleaves. These would be mainly willows. And then there's birch. And I suppose other pines is another big one there at 4. And that's primarily Pinus contorta. So Sitka spruce would be Lycaea agensis. And then looking at the growing stock change, which is useful for the repeated cycles again. So we can track that, and where the volume is coming where the volume is basically, and how it's changing over time. So we're seeing 71 million plus cubic meters in 2006, and it's coming up to 97 million or so in 2012. And again, the share of the private element is increasing substantially from 28 to 38. Again, so it's showing that young forest is coming up and putting on volume in recent years. And again, this is just a breakdown for species of the growing stock volume for 2012. And head and shoulders above everything else is Sitka spruce in terms of the share of the volume, growing stock volume at 59%, and then followed by other pines mainly. So that's our main volume producer. And we look at mean growing stock per hectare. So there's a higher growing stock per hectare in the public. It's more mature forests in the state forests, and 127 in the private, an average of 148. So again, reflecting the age differences between the two ownership types. In the mean annual increment, we're able to estimate as well from 2006 to 7.5 million cubic meters of increment in annual increment between 2006 and 2012. And then we're able to look at the harvesting, mean annual harvesting volume between 2006 and 2012 was 3.5 million. So again, we're able to look at the private, where it's coming out of, and the public. So predominantly harvesting is still in the public part of the forest. So that's kind of an overview of the NFI process and the results, and kind of a look at Ireland's forest and the composition as well. So that's it.
Thank you. It's very interesting from